This is the first video we're going to be doing. I'm going to be going over some of the exams from this year, which have just finished, and they're online, so let's go through them. The only thing I'm going to be using is the most common calculator that NCEA 1 students use, and any formula that they give us. All right, so this first one is Level 1 Mathematics and Statistics. Demonstrate mathematical reasoning. That's kind of a grab bag of all sorts of mathematical skills. They got rid of the MCAT exam and replaced it pretty much with this one. I'll leave to you whether that was a good idea or not, but let's get on with it. All right, so first one is the diagram below shows a cuboid. So I'm just going to explain as we go along. So a cuboid just means that all of the angles are right angles. It doesn't mean it's an exact cube, but it means that it's a bunch of rectangles with 6 sides. So we want to find the total surface area. So notice the surface area is not the volume, where x equals 7. So there's two ways we can do it. We can put x equals 7 into these three numbers here, or we can do it algebraically first and then put the 7 in. We'll do it that way. So the first first two sides is going to be, so this side here, and notice it's repeated on the other side. So this side here is going to be 2x minus 1 times 3x. So when we multiply these two together, we can get 6x squared minus 3x, and we're going to multiply that by 2 because there are two sides. 6x squared minus 3x is going to be sort of this side here, but there's another one on the other side there, so we need to multiply it again. So that's going to be 12x squared minus 6x. So that's two of the sides. Let's use the green one now. So the green one is going to be this side here, and there's going to be another on the other side as well. So that one is 3x plus 2 and 3x again. So that's going to be 9x squared plus 6x, and we need to double that again. So we're going to get 18x squared plus 12x, and so this one is going to be the top, and of course the bottom. So this is going to be 2x minus 1 times 3x plus 2. So 2x minus 1 times 3x plus 2, and then we're going to need to multiply that by 2 again. So multiplying out this brackets, we get 6x squared minus 3x plus 4x minus 2, which equals, if we combine everything together, plus 1x minus 2. We need to multiply that one by 2 to get 12x squared plus 2x minus 4. So now we can combine all of these terms together and substitute with it. So we've got 12x squared minus 6x plus, and I'm not going to put the colours in, I think. So what's going on here, plus 12x plus 12x squared plus 2x minus 4. Now we're going to collect up the like terms. This is probably in hindsight the quickest way of doing it. we've got the 12x squared plus 18x squared plus 12x squared, so that's going to be 242 x squared. So those are the x squareds done. And then x minus 6 plus 12, so that's going to be 6 plus 8x. So the x's are done. Minus 4. Yes, minus 4. Okay, and now we're going to put in 7. So 7 squared plus 8 times 7 minus 4. This is 109. And I can't bother doing it just off the top of my head. So let's grab our calculator. So this is going to be 42 times 7 squared. So it's going to be 42 times 40 times 49 plus 8 times 7, 56, minus 4. So 42 times 49 plus 56 minus 4 is 2110. So the area is 2110. Up a bit. It doesn't tell us 2110, so it's going to be unit squared because it's area. All right, the next one is kind of a simultaneous equation, but it doesn't quite give us what we're looking for. So this line here is x plus 3y equals 19. This one is 3x minus y equals 2. So lots of different ways we could do it. We need to do a simultaneous equation. Let's do it in the kind of cancelling method. Okay. We can make it this equal to x and this equal to x, or this equal to y and this equal to y, and do it that way. So let's kind of do it like this. So x plus 3y equals 19. 3x minus y equals 2. We want to get rid of one of them. Let's multiply this one by 3. So we get 9x minus 3y equals 6. And let's copy the above one up. So I brought this one down to here so you can see it. Okay, so now let's get rid of the y's, and we can do that by adding them together. So 10x plus no y's equals 25. 19 plus 6 is 25. So x is going to be equal to 2.5. And now let's choose one of them. Let's choose this one here. So x is 2.5. So 2.5 plus 3y equals 19. So take 2.5 away from both sides. So 3y is going to be equal to 16.5. So y is going to be equal to 16.5 divided by 3, which is off the top of my head. So let's grab our calculator. 5.5. 5.5. So y is 4.5. So our coordinate where they cross is at 2.5, comma 5.5. again, lots of different ways we can solve that equation, but let's do it in a system equation way. All right, next one. We need to find the perimeter of this triangle here between these points. So diagram, this is 70 centimeters here. This one is 1.2 meters. So you see a problem straight away. And this is 28 degrees here. So if you know your right angle triangles, you're fine, but we need to do something first. So we can't have one in centimeters and one in meters. So what I'm going to do, I'm going to then I'm going to convert this to 120 centimeters. It's going to be a bit easier. All right, so let's find this side here first. And this is obviously a right angle triangle, so we can use Pythagoras' theorem. So the side EB squared is going to be equal to 120 squared plus 70 squared. So I'll grab our calculator. So 120 squared plus 70 squared is that huge number there, and then we want the next bit that we want, so we want to take the square root of that. So I'm going to take the square root. Whoop, 19. So let's clear that. I haven't noted down what it was. So 120 squared plus 70 squared is 19,300 centimeters, of course, and we need to take the square root of that. So EB is going to be the square root of 19,300, which is, calculator, let's take the square root, 138.92. I'm going to go two decimal places, 138.92. Yes, that side there. Now let's do we need to find this side here, and we can find that because of this side here is 70 centimeters, this side here is also going to be 70 centimeters. We've got an angle here of 28 degrees, so we're effectively finding the hypotenuse, and we've got the adjacent, so we're going to use cosine. So cosine of 28 is going to be equal to 70 divided by the hypotenuse. So that means the hypotenuse is going to be equal to 70 divided by cosine of 28 degrees. Grab our calculator. First thing we need to do is make sure that it's in degree mode. That it's not, it's radian mode. So 70 divided by, I'm going to put it in brackets, cos of 28. Ooh, okay, so we've made a mistake. The mistake was that I didn't change over to degree mode. It's still in radian mode, so it should have been in degree mode. It was in radian mode, so let's get out of here. So 70 divided by cos of 28 equals 79.27. So 79.28, I'll say. Alright, now we need to find this side here. Now, this side here we can find if we find this side here. because there's 120 centimeters across, and this side is going to be 120 minus that. So this side here, we're going to use, we're finding the opposite side of the angle, so we're going to use sine. So that side there, so sine of 28 degrees is going to be equal to opposite over adjacent. So the opposite side there over the adjacent side, and the adjacent side is 70. So that side there is going to be equal to 70 times sine of 28 degrees. Sine of 28 degrees. It's that, times it by 70, and it's 32.86 centimeters. So now we have all of the sides and we need to add them up. So it's going to be 32.86 plus 138.92 plus 79.28. Grab the calculator. 38.92 plus 79.28. And we get 251.06 centimeters, and it's 2 each. Yes, that's to that.
All right, this next question is one of the questions that you're probably going to be given in one of your exams. They give you this table and they give you the x coordinate and the y coordinate that goes with that, and they say this makes a graph. What's the equation between them? The relationship. When you read the relationship, you should be reading what is the equation for the graph that goes with that. And we see straight away this is not a linear function. These just grow way too quickly. It just kind of starts at 11 and then...
Boy, that escalated quickly. I mean, that really got out of hand fast.
It jumped up a notch.
It did, didn't it?
Goes to 731. So, given that, it's probably also not a parabola either. So when we come to draw this, it is definitely not going to be a straight line. It is probably not going to be a parabola either. It just grows way too quickly for that. It is probably going to be an exponential graph. So we want y is going to be equal to some number times some other number to the power of x plus c. So it's going to be in that form there. So how do we find this? First thing we have to look at is b. And the way that we do that is by taking the difference of these and then work something out to see if there's a pattern there. So 29 divided, take away 11 is obviously 18. And if I grab my calculator, 83 minus 29 is going to be 54. And then if we get 245 minus 83, we're going to get 162. So it's obviously not parabolic. If this is a parabola, these would all be the same number. And then the last one is 731 minus 245, and that's 486. So That's kind of the differences of the differences. And then what we're going to do is we're going to find the common ratio between those. So we're going to divide 54 by 18 and see what we get, and see if we get this the same number if we divide 162 divided by 54. And if we get the same numbers for these, then we know that we're on to a winner. So 54 divided by 18 is 3. So that's interesting. So 3, and then let's have a look. 162 divided by 54. This one here. That's 3 as well. Okay, so this is really, really promising. Let's do 486 divided by 162. That's 3. Okay, that's fantastic. That tells us B. So now we know B. Now we actually have enough to solve this. B is going to be equal to 3. So from here, it's really just a matter of algebra. We know this 3, and we're going to put these in, and we're going to find the values of A and C. And I'm just going to clear this off a bit. All right, so it's going to be in the in this form: y equals A times 3 to the power of x plus c. And we need to know what A and C are. So for this, we are going to just put the original numbers in and turn it into a simultaneous equation. So I'm going to use just the first 2. So I'm going to let x equal 1, and then I'm going to let x equal 2, and then solve, create a system of simultaneous equations. So for this one here, when x equals 1, y equals 11. So 11 is going to be equal to 3 to the power of 1 is 3 times A plus C. And now we're going to let x equals 2. When x equals 2, y is equal to 29. So 3 to the power of 2 is 9. So 9a plus c. And now we have just a system of simultaneous equations, and we can subtract one from the other. So 11 minus 29 is minus 18. 3a minus 9a is 6a, and c minus c is no c's. It's going to be minus there. So now a is going to be negative 18 divided by negative 16. Negative 6, sorry, which is 3 itself. So a is going to be 3 itself, which is going to be interesting. Now we need to know what c is. So we know that a is 3. So let's just come up to do this one. So 11 is going to be equal to 3 times 3, which is 9, plus c. Take 9 away from both sides, and we see that c is 2. Now we actually have everything that we need. So we know that y is going to be equal to 3 times 3x plus 2. But you can't really leave this 3 there. If these are the same numbers here, we could rewrite that as 3 to the power of x plus 1. So 3 to the power of 1 times 3 to the power of x, if you remember your indices, is going to be 3 to the power of x plus 1. And here is our final answer. All right, we're back. So the next one says they want 3 different features of this graph using the equation we found. Well, let's grab our calculator and graph it. And the reason I sort of hit pause there is we have to sort of play around with the zoom. This is going to be an exponential function here. let's actually zoom out just a little bit. So it's going to kind of have that classic exponential bow shape, and it wants three features of that. So the first thing we would say, we would want to find the y-intercept, because obviously there is one, and we need to know what it is. So if y equals 3x plus 1 plus 2, how do we find the y-intercept? We set x equal to 0 and solve for y. So y is going to be equal to 3 to the power of 0 plus 1 is 1 plus 2. So y is equal to 3 plus 2, which is 5. So the y-intercept is at 0, 5. Okay, the second feature. Let's move up a bit. The second feature is common of all exponential functions, and that is it's probably going to have a horizontal asymptote. Okay, so that means that if we get it from here and we zoom, looking kind of like that, it's going to get closer and closer and closer to the x-axis, but it's never actually going to get there. At x equals y equals 0 actually. Okay, so let's kind of prove that. So we know that y is going to be equal to 3x plus 1 plus 2. So finding the x-intercept, if we tried to find the x-intercept, we would set y equal to 0. So 3x plus 1 plus 2 equals 0. Let's bring this 2 across. Okay, now to find that, we need to take logarithms. So x plus 1 comes out the front. We take a log there of 3. So this is fine. This is cool. But if we take a log of a negative number, we can't do it. Okay, so just this is sort of prove it. Well, kind of prove it. Log of negative 2, it's going to give us math error, non-real error. So there is a solution, but it's in an imaginary complex form, and you definitely do not need to worry about that at this time. So there is no x-intercept. Okay, that's feature 2. What's the so there is no x-intercept. Okay, so for feature 3, I'm gonna say what's the domain and the range. So from that we can say that the domain is all values of x, and the range, that's the y value, is all real numbers greater than 0, and that's a feature. It never goes below the x-axis. It just kind of goes forever and ever, getting ever and ever and ever closer to the x-axis, but never quite getting there. And then up here, it kind of balloons up forever and ever and ever. All right, question 2. So what's the information that we need to know here? So we want to find the value of x, and what do we know about any triangle? All of the angles add up to 180 degrees. So therefore this angle plus this angle plus this angle have to add up to 180 degrees. So with that, x, which is this angle here, plus 2x plus 10 degrees, and I'm not going to put the degree symbol, plus 3x plus 50, is going to be equal to 180. So now that we have this, we can now solve for x. So let's collect up all of the x's. So 1x plus 2x, 3x, that's 6x. They're all done. And 10 plus 50 is 60, and that equals 180 degrees. Let's take 60 away from both sides. So 6x is equal to 120, so therefore x must be equal to 20 degrees. That's that one done. Next one is a 3D trigonometry question. So we need to really read the questions. So all of these are right angles. And if FS is vertical, this one here, and is perpendicular, meaning at right angles to this one. So these are all right angles around here. So kind of imagine this is like one little corner of a room here. And the end result is that we want to find this one here, which is x. Okay, so given these are all right angle triangles, we can use trigonometry. We could use a thing called ratio of tangents, but I'm just going to use the tools that you will have in the exam, well, that you had in the exam. So first thing we are going to work out is probably this one here, because we can work this one out straight away. So if this is 8 and that's 32, if we kind of draw this triangle, so this triangle here off to one side, so that's our x, and sorry, that's not our x, is it? No, we don't want that yet. We can't find that one yet. We're finding this triangle here. So this is 32 degrees, and this is 8. If we want to find this side here, which is SF, what are we going to use? Well, we're finding the opposite, so we're going to use sine. So sine of 32 is going to be equal to SF over 8. Remember, opposite over hypotenuse, so therefore SF is going to be equal to 8 times sine of 32. And grab your calculator, make sure it's in degree mode, which I just did. So sine of 32 is that, times that by 8 is 4.23. 4.2, we'll say 4.24. Okay, so this is 4.24. Let's put that on there. Okay, now this one, we need to find this, the length of this side here now. So to do that, we're actually going to need to find, we're going to need to deal with this one here, and to do that we're going to need to find this side here. So this one is the other side, so this is going to be kind of the converse of that. Instead of sine 32 times 8, it's going to be cosine of 32 times 8. And we grab our trusty old calculator. So cosine of 32. Now in these CASO calculators, I always do this separately, and I'm going to multiply that by 8. So 6.78. 6.78. Okay, now we've got one of the sides, and we've got this angle here, which is 43. Now we can go ahead and find this side here, which is FG. So let me just move that up a bit. So FG is, the angle is 43, and we are looking for the adjacent side. So we're going to use the tan. So if you remember, tan is opposite over adjacent. So we've got the opposite side and we're looking for the adjacent side. So it's going to be the opposite side divided by tan of 43. So the opposite side, which is 6.78, which we just worked out, divided by tan of 43. And it's going to be some number. And that number is 7.28. So this side here is 7.28. So now we have everything we need to find x. We're now finding this triangle here. So let me just redraw the sides here so we can kind of work with it. So we know there's a right angle here. This is 4.24, whatever it is, and this is 7.28, and we're looking for x. So now we are going to need to use inverse. We've got opposite and adjacent, so we're going to need to use tan inverse. So x is going to be equal to tan inverse opposite over adjacent 4.24 divided by 7.28, and it's going to give us our final answer. So 10 negative 1 4.24 divided by 7.28, and we get 30.22 degrees. And that's that. We're done with that one. At least. Well, actually, at most. Okay, this one asks us to factorize and then a big, huge capital S and solve the equation below using an algebraic method. So don't just bang it in your calculator and find the answer. They want to really show the answer. So this has to be in the form ax squared plus bx plus c equals 0. And once you've done that, I mean, you could do two things. Well, a few things, the quadratic equation, but they want you to factorize this. They explicitly want you to do that. So let's bring these two over. So 15x squared plus 7x. Remember, we add 7x and subtract 2. And subtract 2 equals 0. And now we can factorize it. So the 15 out the front here times negative 2 gives us negative 30. So we want two numbers that multiply to give us negative 30 and add to give us positive 7. And it's pretty obvious straight away. This is going to be plus 10 and minus 3. So I'm going to put that there. Whoops. Okay, I do several videos on this, so I'm just going to go ahead and solve it for us. So what's the common factor here? It's going to be 5x. And the common... that there, and plus 2, and now we want 3x minus 2 there. What do we have to multiply that by? Negative 1. So collect the terms outside the brackets and the terms inside the brackets. Okay, so we've factorized it. Now they want us to solve it using factorizing. So if this one times this one equals 0, either 5x minus 1 equals 0, or 3x plus 2 equals 0, or both of them. So we're going to add 1 to both sides. 5x equals 1. So x is going to be equal to 1/5. And for this one here, we're going to take 2 away from both sides. and divide both sides by 3. So x is going to be equal to negative 2/3. So our answer is 1/5 and negative 2/3. So the main problem there would be if you didn't know how to factorize that, you'd be in trouble. You either know this one or you don't. Right, this one, they give us a whole bunch of information and we have to do several things. It's a pretty involved question, this one. So the diagram below shows cross-section and plan of a large hole to be dug in the ground. Top section is a cuboid, so this box thing here is a cuboid, and the hole is symmetrical about PQ. There we go. And all sides are vertical. It is known that 1 meter cubed of earth weighs 800 kg, and one truck to transport 45 tons of earth in one single load. Well, straight away we have different units for mass, but 1 metric ton is equal to 1,000 kilograms. Okay, calculate the number of truck trips required. So we have to do quite a lot of stuff. We have to work out the volume and do that. So let's do that straight away. So let's work out the cuboid, but at the top here. So this has 5, and this is 30, and this is 20 deep. So 5 times 30 times 20 is going to be what? We're going to grab our calculator. You could maybe do this in your head, but we'll do it on the calculator. 3,000. So this is 3,000, and this is going to be meters cubed. So that's the cube done. Now we have to do this sort of, essentially it's a prism. So we have to work out the face area there, and if we do that, we can see that it's symmetrical, and this is 30 cross, and this is 25. So the area of that face is going to be half the base times the height. So we need that distance there. But we've got a right angle triangle, and if this is symmetrical, this side from here to here must be 15. Now we can use Pythagoras' theorem. So let's call that x. So 25 squared is going to be equal to x squared plus 15 squared. So x squared is going to be equal to 25 squared minus 15 squared. So x is going to be equal to square root 25 squared minus 15 squared. And that's going to give us some number. So let's take the square root, and then we need to put brackets, especially in these Casio calculators, minus 15 squared, close the brackets, and we get 20. Okay, 20. So therefore, the area of this triangle is going to be half the base times the height. So it's going to be half times the base is 30 times the height, which is 20. So it's going to be equal to some number. So half 0.5 times 30 times 20 is 300. So that's 300 meters squared because it's the area. And now we want to convert that into volume by multiplying down here, and this is 20. So the volume of that kind of prism at the bottom there is going to be 20 times 300, which is going to be 6 and 3 zeros, 6,000 meters cubed. So how much have we got in total? Well, we had 3,000 in the cuboid, plus 6,000 in the sort of prism, the triangular prism there, and that's going to give us 9,000 meters cubed. Okay, now each cubic meter is 800 kilograms. So the mass of this is going to be 9,000 times 800, which is going to be some huge number. It's going to be what, 72. Okay, so 9,000 times 800, 72, and then 5 zeros. 2, 3, 4, 5. So 7.2 million kilograms. And we know that each truck carries 45 tons, which is 45,000 kilograms. So the number of trips, which is our final thing that we're trying to work out, is going to be this number here, 720000. Yep, divided by, and I forget now, 45,000. It's going to be some number. And that number is, let's divide that by 4,500. No, 45,000, isn't it? 45 tons, 45,000. Do that again. Divided by 45,000 equals, drum roll, 160. Exactly. 160 truckloads, which is truckloads of. And lastly, question 3. Find the equation of the straight line L shown in the diagram below. Okay, so to find a straight line, we need 2 points. Here's a nice point there. So that point is 5, 0, and what's another good point? 4, 3. Any 2 points will do. Straight away, just looking at it, we can see that it's going to be a negative slope. And in fact, we can just read the slope off because it's 1 across and 3 down. So m is going to be -3, isn't it? So with that, let's choose one of these points and put it in. So y minus y1 is going to be equal to mx minus x1. Y1 is 0, so that's going to stay there. This is going to be -3. X now -5. So let's move this up a bit. So we want to expand out the bracket. So y is going to be -3 x plus 15, and that kind of would make sense. If this kept going up there, it would be around about 15. Yep, so far so good. Okay, the next one is find the equation of the parabola. So there's a couple of ways of doing this. We can see that the x-intercepts are at 3 and -5, and the maximum point there, the turning point, is at -1 at 6. Let's actually, I'll just sort of take a side swipe here. Let's do it both ways. So I'm just going to pause the video for a sec. So 2 ways we've got of doing it. We can do it using the vertex form. So y is going to be equal to x minus h squared plus k. Actually, there's very important, something that we've missed out the front there. It's going to be equal to some number ax minus h squared plus k, where h and k are the coordinates of the turning point. So y is going to be equal to some a x, and this is going to be plus 1 squared plus 6, and now we need to find out what a is, and we would do that by taking one of these points. So x equals 3 and y equals 0, so 0 equals a 3 plus 1 squared plus 6, and then solving for a. So this is going to be 3 plus 1 is 4, 4 squared is 16, so 16a plus 6, and let's take the 6 away from both sides. So 16a equals negative 6. A is going to be equal to negative 6 over 16, which is negative 3 over 8. And that's going to give us a equals negative 3 over 8, x plus 1 squared plus 6. And then we would find whatever that is by expanding out the brackets. In fact, let's kind of do it. So it's not going to be x, it's going to be y, isn't it? Y is going to be equal to negative 3x plus 1 squared, so plus 6. So x plus 1 squared is going to be x squared plus 2x plus 1 times, and this is going to be negative 3 over 8 x squared plus negative 6 over 8 x negative 3 over 8 plus 6, and 6 minus 3 over 8. Sorry, it's late at night while I'm doing this. So 6 minus 3 over 8 is 45 over 8. So our final answer is going to be negative 3 over 8 x squared, negative, and I guess we could simplify this again, negative 3 over 4 x plus 45 over 8. Gee, that's a mouthful, isn't it? The other way we've got of doing it, the other way we've got of solving these types of questions is if we have the intercepts, we know that it's going to be in the form y equals some number x minus the first root x minus the second root, and we know that root 1 is at negative 5 and root 2 is at positive 3, and then we would solve for a and we would put in this turning point that we've got, so it's going to be negative 1 6. So let's do that now. So y is going to be equal to some number a, x, and minus is plus 5, x minus 3, and now we wherever we see an x we're going to put negative 1, wherever we see a y we're going to put 6. So 6 is going to be equal to a negative 1 plus 5, negative 1 negative 3. So that's going to be a times negative 1 plus 5 is positive 4 and negative 4. So 6 is going to be negative 16a. A is going to be equal to negative 16 over 6, which is the same as we had before. So our answer we could put is y equals -8/3 x plus 5 x -3, and expand that out, and we would get the same answer that we got over here. I'm not going to do that. It's going to be pretty trivial. We've already got the answer there. Either one will give you the answer. There's a couple of other methods as well, but that's the most immediate way I can see of doing it. We could do it into a three-way simultaneous equation, but probably not. We're nearly at the end. This is the second last question. So the diagram below shows a quarter of a circle with a radius of p. So in other words, r equals p, and the centre here at C. Calculate how much longer the curve FGH is than the straight line FH. There are a couple of, well, there's one formula that will give you the answer straight away, but you're not given that, you're not expected to know that. So let's work it out by first principles. We know that the circumference of a circle is 2 pi r, and we know that this is a quarter of a circle. So we divide that by 4, and we know that r equals p. I just put that up there. So the circumference of the length of this line here, this arch around here, is going to be equal to pi p over 2. So that's that one. Now we need to work out the length of this, and we know that this is a right angle triangle. So this bit here, this length here, let's call it let's just call it x. So x squared is going to be equal to p squared plus p squared, which is 2p squared. So x here is going to be equal to the square root of 2p squared. Okay, so that's going to be equal to, let me have a think about that. Yes, okay, I think, yeah, if we separate those out, that's going to be equal to square root of 2. So we're going to get a third, aren't we? And then square root of p squared, which is p. Okay, so let's combine them. It just seems a bit messy. So the difference, therefore, is going to be equal to pi p over 2 minus square root 2 of p. I guess we could leave it like that. I mean, I guess we could factor out the p. Pi over 2 minus square root of 2. I don't think we can simplify that anymore. There's a 2 there and 2 there. No, I'm just going to leave it like that. I think it's as simple as it's going to get. Interesting question, though. Interesting question. Okay, so for this one, I have to admit I kind of break my own rules for this one. I sort of looked down and I thought, oh, this is going to get ugly fast. So I had to do some frantic scribbling. Okay, so the area of the right angle triangle is given as 72 centimeters squared. And we know that this side here is x over 4. I kind of rubbed it off. And this one here is 41 over 8. So therefore, this side here, RS squared, is going to be equal, plus this squared is going to equal this squared. That's one thing. And half of this times this equals 72. So let's do that first. And what we're going to want to do is we want all of these sides in terms of x. The these two sides here are already in terms of x, so we want RS in terms of x. So let's use the 72 centimeters bit first to put RS in terms of x. So half times the base, which is x over 4, times RS equals 72. They give it to us. Half times x over 4 is x over 8. So x over 8 times RS equals 72. So that means that if we kind of join up these brackets, RS times x over 8 equals 72. And what I'm going to do, I'm going to multiply out the 8 here, I think. Oh, even now. Yeah, that makes sense. 8 times 72. So RS times x is going to be 72 times 8. Grab a calculator. 72 times 8. 576. So therefore RS is going to equal to 576 over x. Okay, so 576 over x. Okay, so now all three sides are in terms of x. Now we need to find what x is. Now if we already used the area thing to find RS, we can't use RS to use the area, so we need to use Pythagoras' theorem now. And now I think is where it's going to get really, really, really ugly. But let's do it. Okay, so we know that 576 over x square plus x over 4 square is going to equal 41 over 8 x square. Put a little line there. So let's expand out the brackets. So this is going to be 576 squared over x squared plus x squared over, and 4 squared is 16. And this, when we squared something which is already square rooted, we get 41 over 8, and now we have to square the x squared. And what I'm going to do there, I'm going to put the x squared up here. Okay, now this 576 squared bit, let's find out what that is. So 576 squared is this huge number, 331,1776. If you're American, that will probably mean a little bit to you. Now, it could get really, really, really messy right now. We could have all sorts of ugly things going on. We need to cross multiply, we need to use fractions, but I'm going to get rid of the 16x squared, because remember when we have a over b plus c over d, it's b times d at the bottom. So I'm going to multiply each term by 16x squared to get rid of it. We can do that as long as we do it to both sides. So 16 squared times 331,776 over x squared is going to give us whatever 331,776 times 16 is, times 16 equals this enormous huge number. Five three oh four, sorry, 8416 x squared over x squared, and they're going to cancel. And that's great. That's fantastic. So let's do it with this one as well. 16x squared times x squared over 16 is going to give us 16x to the power of 4 over 16. These 16s are going to cancel, and we're going to be left with x to the power of 4. Okay, now we want 16x squared times 41 x squared over 8. And that's going to give us whatever 16 times 41 is. Uh, 656. X to the power of 4 divided by 8, which is 82. Okay, so we've got 82 x to the power of 4. So let's line all these things up. So we have 5 3 0 8 4 1 6 plus x to the power of 4 equals 82 x to the power of 4. And let's take this x to the power of 4 away. And we have 5 3 0. Have we made a mistake there? I think we made a mistake. No, I just panicked. I thought, oh, if I made a mistake there, it seems a really huge number. Nope. Is going to be equal to 81 x to the power of 4. Now we want to divide both sides by 81, and there's a lot of algebra in this. I think this is definitely an excellence question, this one. So this one is 5308416 divided by 81, and it looks promising. 81's perfect square. 65536. 536 equals x to the power of 4. We're nearly there. Let's take the fourth root of both sides. Oh. So that's the same as raising it to the power of a quarter. I'm taking the fourth root. Whoops. And the answer is, drum roll, 16. So x is 16. So I have to admit, I did actually need to do quite a bit of scribbling, and I got an answer that was just wrong. I thought that just can't be the answer. And I had another go, and I thought, no, I need to simplify this as much as I can. So hence the 16x squared, but you would eventually get the answer, but it will probably take ages to get that answer. And you're going to need to take the fourth root of some huge number and then divide that to get 16. But that's the answer, and that's the exam. So an interesting exam. Some questions really, really easy, and some really challenging. I mean, should be able to do this, but it takes ages to do. It took me ages to do, and I'm a professional mathematician, so yeah, it would have really excelled students who were looking for excellence. This was reasonably easy. This was, you need to know what you were doing, and this was just knowledge of how the metric system works and how to find volumes. But otherwise, yeah, a pretty good exam. I wouldn't say it was an enjoyable exam, but it was an exam.
Let's kick some ice.